So let's take a look and see if this observation matches the globe perspective view. In part 1, I showed that the perspective view or angular size measurements do not match the flat Earth, because if that was the case, Snaefell and the Isle of Man would be way up here. But first, let's take a look at this well-known flat Earth meme, perspective hijacking Earth curve calculator put forth by math illiterate Nathan Oakley. And I can call him that because he once argued that you do not divide meters by 1,000 to convert them into kilometers. So again, if we are talking about perspective, we are talking about how big an object appears to be, and that would be the visual angle, which is the angle a viewed object subtends at the eye, and it is also called the object's angular size. So there are two ways we can measure any object that we see, and the first is the actual size that does not change with distance. So of course, no matter how far away this building gets, it is always 1,200 feet tall. And of course, the second method is the angular size, which of course does get smaller with distance. So perspective does not change the physical world, and this is why we use actual sizes and distances for geometric calculations. So let's use an example of a 6-foot viewer height at 30 miles, which gives us a geometric hidden of 486 feet. Now, since we know the building is 1,200 feet tall, I think it is quite obvious that it makes more sense to use a hidden value that is also in feet. So Nathan, if you really think it's important to know the angular size, do what I did. Do an angular size calculation. In this case, 486 feet at 30 miles is 0.176 degrees in angular size. And the angular size of a 1,200-foot building at 30 miles is 0.434 degrees. But guess what, Nathan? This changes nothing, because the ratio of the hidden to the building is exactly the same whether you use feet or angular size. So let's start with part 2, and we'll see if this observation matches the globe perspective view. And again, I will begin with Snaefell. Now, exploring the plane did have very good data, and he had an eye height of 940 feet, target distance 89.5 miles for a target hidden of 1,800 feet. Now, when I did a measurement from his location to Snaefell, I got a slightly longer distance, 89.65 miles. And when I plug that distance into the curvature calculator, I get a slightly larger geometric hidden of 1,810 feet. And when I subtract that from Snaefell's elevation of 2,037 feet, we have 227 feet that would be visible. So this is the triangle formed by that 227 feet of visible, and when I do an angular size calculation, we get 0.027 degrees. So I'm just going to round that up to 0.03 degrees. So let's compare that to these turbines at the West of Duden Sands wind farm. Now, as I told you in part 1, I was able to insert a map of that wind farm into Google Earth, and the front edge of the wind farm is at 42 miles. And at that distance, we have a geometric hidden of 13 feet. The turbines are 492 feet to the top of an upright blade. So when we subtract the hidden, we get a visible height of 479 feet. And that gives us an angular size of 0.124 degrees. So I'm going to round that off to 0.12 degrees, and like I did with the flat Earth, I'm going to draw a line across the top of this turbine and this turbine over here, since they both have upright blades, and here is my angular size ruler that is scaled to 0.12 degrees. So this is not a close match, because this shows that Snaefell should be somewhere down in this area. But it is a better match than the flat Earth, which at 0.25 degrees would put Snaefell way up here. So let's take a look at the refracted hidden. and that is 1,378 feet, which gives us a visible height of 659 feet and an angular size of 0.0797 degrees. And I'll round that up to 0.08 degrees. Now the turbines only have a refracted hidden of 1 foot. So we have a visible height of 491 feet and an angular size of 0.126 degrees. So I'll round this up to 0.13 degrees and adjust my ruler accordingly. Now this line here goes through 0.08 degrees on my scale, and this shows that the refracted hidden calculation is the closest match for this observation. Now another thing I want to point out is that these turbines are sitting right on the horizon, and the front edge of this wind farm is about 42 miles away, which is very close to both the refracted horizon of 40.55 miles and the geometric horizon of 37.55 miles. And I want to point out something else. This is a blow-up of this area here, and you can clearly see that there are 3 turbines here where most of the mast is hidden by the horizon. Why would we see this on a flat Earth? And here's another example where measured evidence supports the globe. The refracted hidden is the best match, followed by the geometric hidden, and dead last, way up here, is the flat Earth. And this should not be surprising because this matches the data supplied by exploring the plane. First, exploring the plane is correct. This observation does not match geometric curve calculations, and everything below the red line should be hidden on a globe. But this is flawed flat Earth logic because falsifying the globe does not prove that the flat Earth model is correct. Because where is this evidence that this observation matches the flat Earth model? In fact, the data he supplied in the graphics show quite the opposite. So this right here from the red line down to sea level is 1,800 feet, and all of these lines are 200-foot increments. But when we look at the photograph, does this really look like it would be 1,800 feet of the Isle of Man? Now up here, these 2 yellow arrows point to 2 saddles between ridges that are to the right of Schneefel, and these are the same 2 saddles on his elevation profile. So what I'm going to do is I'm going to take a cutout of this area right here, and I'll paste it to this wide-angle shot of the Isle of Man. And here I have adjusted the lengths so Schneefel, North Barul, and these saddles line up with each other. And then I have used this box right here, which I copied and pasted right here to adjust the vertical height, so this is a close match to what we see in the photograph. Now again, these horizontal lines are at 200-foot increments, so this would be 1,400 feet right here. So next I added this shaded area and I aligned it to the bottom of the box right here. And all of this should be visible on a flat Earth. And here we have flat Earth logic on full display. So this discrepancy of about 250 feet for the geometric horizon is not a match with what we observed, so that is the globe killer. But this discrepancy of almost 1,400 feet, well, why would that be a problem for the flat Earth? Now, exploring the plane tried to explain this away with angular compression and the diffraction limit. Now, of course, this really doesn't make any logical sense at all. So this area here is an estimation of what is missing on the Isle of Man. And look how thick that is in angular size. So if this area is below the diffraction limit of the eye, why can't I see this thin area of the Isle of Man, and this little thin area, and this thin area, and this thin area? And why can't I make out small details like all of these wind turbines? And why can't I even see individual trees that are smaller than the missing part of the Isle of Man? So you really got to ask the question, is this complete ignorance due to self-indoctrination from a diet of watching too many flat earth videos? Or is this just blatant dishonesty? But actually, I'm going to say thank you, Exploring the Plane, because since Ranty has woken up and smelled the coffee in regards to the globe, I think it's time that we recognize the work of other flat earthers who actually go out and do the field work to provide evidence that supports the globe model. Because here's another photograph where measured evidence supports the globe.